Hello, everybody. Welcome back to another episode of the MP Sanders podcast. Again, we're doing the geoscience series today. One of my best friends watched the Younger Dryas episode, and he told me I should do an episode on man-caused climate change, especially because he saw the little tag under the Younger Dryas video talking about the climate change thing. So I had a goal of doing that anyway soon, but my original goal was to make a Graham Hancock episode today. But I backed away from that solely because the idea I have for that is going to take a little bit of time because I want to, watch his show, get clips from his show, watch his podcast appearance, and respond to specific things he says. So it's just going to take some time getting all of those clips put together and getting my reaction to them recorded and things like that. So when I got home from work today, I was just kind of bored, and I was like, you know what, let's write up a climate change episode. So it's obvious that climate change is a pretty hotly debated issue, and it's very controversial, and I don't necessarily think the root or source of the controversy is in the data or scientific investigation part of it. I think it has a lot more to do with the fact that it has been heavily politicized. This is the most primary example of politicized science, and that should mean something coming from me because of how much time I spend talking about psychopharmacology with recreationally used drugs, because drug science has absolutely also been raped by politics. But it is even more present here with environmental science and climate change. So let's go ahead and get into this. Now, to start, let me turn my mic down a little loud, sorry. So, to start, humans have undeniably had a warming effect on the planet. It is literally physically impossible that we have not induced a sort of warming, and this is due to our greenhouse gas emissions, which most people are perfectly aware of. But something that isn't spoken about so much is that we have also undeniably had a cooling effect on the planet. And this is where a lot of the uncertainty comes from in this science, and it is annoying that this uncertainty is literally never discussed outside of really technical science papers and IPCC reports. If you talk to someone just on the street or on Twitter or you watch the news, you'd think that we have everything lined out perfectly and we know exactly what's going on. And one thing you'll find as you investigate environmental science, not even necessarily from this podcast episode, but one thing you'll notice about environmental science is that there is uncertainty in everything. We don't have anything completely figured out, and one of the reasons for that is, what does the word environment actually mean? It essentially means everything. It means what's going on our planet as a result of the impacts from space, the impacts from volcanoes and earthquakes and ocean circulations and all sorts of shit that we can't really quantify perfectly because there are so many variables. So just starting this conversation, that needs to be lined out immediately. That needs to be one of the first things said, is that there is a high degree of uncertainty in the data. And I'm going to go over that here in a little bit in decent detail. I'm going to bring up really one major example of it and then a couple other ones. But that's going to be the goal here, is just trying to identify this uncertainty and then talk about how this topic is being discussed in a way that I consider harmful by both sides of the political spectrum. So let's start with the warming. That's really the more pressing situation here in terms of how this topic is usually discussed. Although, I would say in the grand scheme of things, if the planet was cooling down, we would be in much more trouble than if it is warming up. And that's something else that I rarely hear spoken about. If you look back through the Holocene, even when civilization existed, some of the most catastrophic periods of human history were during cooling periods. And one thing associated with cooling periods are outbreaks of plagues. Like the Justinian plague was the result of a very, very cold couple of years. And then, of course, you had the Black Plague during the Little Ice Age. So when the planet cools and crops start failing and livestock start dying, that's when shit gets really scary. When things are warming up, you see explosions in human population. You see people traveling all over the world, planting plants in areas that weren't growing before, which is what you saw in the medieval warm period, like I talked about with the Younger Dryas, where you had people farming in Greenland in areas that are now covered in permafrost. So anytime the warming comes up, one of the first things mentioned is CO2, carbon dioxide. And CO2 is a quintessential example of a greenhouse gas. And I don't necessarily think I need to define what a greenhouse gas is. The phrase is sort of self-evident, right? But whenever I ask someone what the most common and potent greenhouse gas is, I almost never get the right answer. And that is indicative of a problem regarding this topic. So, the most potent and common greenhouse gas is water vapor. And, whenever I tell that to people, they're like, oh shit, of course. Like, the humidity affects temperature immediately. And it can change over days or weeks and even hours, and you'll see temperature changes relative to this. The fact that when you say greenhouse gas and people don't think of water vapor and relative humidity and they think about CO2 is just sort of indicative of this phenomenon, like this phenomenon of non-scientists trying to talk about very technical scientific topics. Regardless of all that, over the past 150 years or so, there has been a warming on the planet, and we have roughly doubled CO2 concentrations in the atmosphere. And of course, this has a direct warming effect on the planet. And the way this works is rather simple. I won't necessarily go deep into the chemistry of it, but whenever CO2 interacts with infrared light, which is heat, it excites an electron and absorbs the infrared. And then whenever that electron comes back down and calms back into its original shell, it ejects the infrared light back out in a random direction that's ultimately impossible to predict. But the more CO2 you add to the atmosphere, the more heat that is being shot back towards the Earth. Right? Sometimes it gets shot out into space, but the other time it's going straight back to the planet. So the more CO2 molecules, the more times the latter is happening. And this cycle of absorption and rejection is constantly occurring. And this is also true of other greenhouse gases like methane. And methane is not spoken about as often, which I think there's a couple reasons why that is, but to be clear, methane is about 30 times more potent in terms of its heat trapping and reflection ability than carbon dioxide. But the difference is that methane does not stay in the atmosphere near as long. So if we were to find a way to change our methane emissions, which unfortunately are a direct result of agriculture rather than coal plants, because most of the methane comes from, this is not a joke, but from farting and burping cows. Because we have so many cows now that we're using for agriculture that they are playing a direct role in the heating of our planet, which is, I don't know, it's kind of funny to me in a way. But so that one may be a little bit harder to solve in the long run, because we're probably going to need those animals in this type of agriculture for a pretty long time until lab-grown meat can become more viable. And even if it does, I think it'll be a really long time before the majority of people on Earth are willing to eat lab-grown meat. Anyway, if we were to be able to find a way to sort of lower our methane emissions in the next decade, we would see a direct result of that in terms of methane concentrations in the atmosphere within like 30 to 50 years. With carbon dioxide, it will take centuries before we notice a difference if we were to stop all CO2 emissions tomorrow. So I think that's really the main reason people focus on CO2 more than methane, even though methane traps and reflects more heat. But in the long run, it's obvious that CO2 is the bigger issue if we keep emitting it at the rate we are. Talking about this topic requires a bit of nuance that is kind of rare when discussing it with people on social media or just the average conversation about climate change. But there's a caveat here. There are people who do what I call pseudo-nuance, where they're having nuanced opinions on things that don't require nuance. Like Nick Fuentes is a perfect example of this when he refuses to call Hitler a bad person and has this really nuanced view as to why he won't say that. When it's ultimately just like, you either just want to be different or you are a Nazi, which is not a term I throw around very often. But so there is that issue, and I just want to make clear that I don't think I'm being nuanced just to be nuanced. Like, as you'll see, there are specific things that actually need to be discussed and lined out and determined before we can start actually saying definitively what is going on right now. And one of those bits of nuance does revolve around CO2 emissions. I can't tell you how often I talk to people that are like, oil companies are to blame, and like they're just shitting on human beings for CO2 emissions, when the fact is that emissions of CO2 up until very, very recently were a survival mechanism. We had to do this to be able to keep our society afloat. So it wasn't like these malevolent people were chuckling at their table while they ruined the planet even though they didn't have to. we weren't thinking about that because we didn't ultimately have the ability to think about that. CO2 powered our society and our economy. But now we are at a point in society where we can actually start looking at other options and try to back away from carbon-based fuel. But we have to back away from carbon in a good and slow, deliberate way. You can look at a country like Germany, for example, who went really hard with this sort of net zero idea, and their energy prices are 70% higher or more than the EU average. They're much higher than they were before 2020, before they went down this road. The unfortunate truth about this is that raising energy prices doesn't fix the environment, but it does displace and literally kill poor people. When energy prices are raised, it doesn't ultimately affect the upper class, and it may have some impact on the middle class, but the lower class are suffering when they can't afford energy. And that's a side effect of backing away from carbon too quickly. And one of the reasons for that is if you completely rely on renewable energy sources like wind and solar, you essentially have to have two fully operational grids in place at once. Because on days where the wind isn't blowing and the sun isn't shining, you still have to have something reliable to fall back on to avoid like rolling blackouts. And that's obviously going to raise prices when you have to build an entirely new and functional grid on top of the one you already use. And of course, it becomes a reasonable conversation to say, well, are these unfortunate casualties and displacements worth it? Because if you are operating off the assumption that if we don't make a change right now, our grandchildren are going to be dying, and it's going to be more poor people in the future dying, then you can kind of make the pragmatic executive decision to say, well, look, I know this is going to suck for a few decades for certain people, but it will be less harm than it would be in 80 years. I don't think the evidence supports that at all, which is what we're about to get into. And I want to be clear before I move on to the more technical, hard data about climate change. Every single source that I use in this podcast, this is kind of just a general statement for the podcast. Every source comes from distinguished, prestigious, peer-reviewed journals. And that is particularly true in this episode. I do not cite people like Randall Carlson or even Stephen Koonin, who is a pretty reputable environmental scientist and physicist, but he is also may have conflicts of interest. He was a BP physicist for a while, and he was also the energy undersecretary or whatever for Obama. So, I try to avoid those types of people and organizations. So a lot of the data I'm about to use comes directly from the IPCC, and the rest comes from prestigious journals like Nature, for example. There are a few facts that cannot be escaped by the climate extremism people and the people who say that humans are the only cause of this modern climate change. And one of the first ones you need to discuss is that the warming started before we started pumping CO2 into the atmosphere. And we know, for certain, we know this, right? We saw the ending of the Little Ice Age in a slight increase in temperature before we started emitting CO2. So that raises a couple questions, right? So first, you need to identify how much we expected that warming to go, but you also need to identify, if you're willing to say humans are the only cause of this, you need to prove that that warming stopped before we started emitting CO2. Because if it didn't, that adds a layer of uncertainty that you need to cover later on. And unfortunately, I have not found anyone who has done that. Even, the IPCC is pretty willing to acknowledge this warming that took place. And I haven't seen a mechanism for why it started warming, which is something I'm going to talk about a little later because that gets a little confusing really fast. But it's just, that's the first layer of uncertainty here. It's like it was already warming. We don't really know by exactly how much, and we don't know how much it would have warmed if we weren't here. So again, that's just a immediate problem with the idea that we are the driving or only force of this climate change. Now, the other thing that needs to be mentioned early on is that the years immediately preceding this warming that we are experiencing now were the coldest the planet had been since the Younger Dryas. There was no other point in the Holocene where average temperatures were that low. And we are coming out of that now. And so we have to talk about a baseline here. Because when you look at something like the Little Ice Age, which is what we were experiencing before. It was very cold, like I said, and as we've started warming up and these glaciers and ice caps have started melting back, we've been finding frozen forests beneath them. There were forests growing in those areas during the medieval warm period. So we have to identify an effective baseline. And I don't think using the coldest average temperatures that the planet had experienced in the past 10,000 years is a good baseline. Where do we set the baseline? Because take a look at this graph. I brought it up a couple times during the Younger Dryas episode, but this hasn't been a straight line. It's been very calm and predictable compared to the Pleistocene, but there are still oscillations here, like in the Minoan warming period and the medieval warm period and the Little Ice Age. Like, it's hard to identify a proper baseline here. And I don't think the baseline should be when we started emitting CO2, solely because it was fucking cold before we were emitting CO2, colder than it had been in the entire epoch in which we currently live. Let's start talking about the uncertainty. I'm going to start basic and slowly move into the more technical stuff. So one really easy way that we can identify how uncertain everything is right now is just looking at the climate models. We can take a specific model like the one on the screen now and see that there are enormous margin of errors. And while this may seem like, oh yeah, well of course there are, it's like, yes, there are margin of errors here because we lack the ability to quantitatively state what is happening right now to a degree of high certainty. Right? There's no other science that would accept this level of uncertainty with something as important with making definitive claims. For example, if we were going to send an astronaut to Mars, but we said, hey, there's a chance that this propulsion mechanism is going to be 50% faster than we think it is, making you completely miss the planet and die in space, we'd be like, well, why are we doing this then? We need to figure out what's going on. And that's sort of the way I view this, right? With this level of uncertainty, we need to be really careful about the claims we make, and we also need to be careful about the policy decisions we make. Because I'm not convinced that what Germany did was necessary to begin with, especially with how uncertain it is right now. And this is in no way meant to criticize environmental science. I love environmental science. I'm about to enroll in a graduate degree in environmental science, and like I said in my last episode, my 10-year goal is to be a professor of this topic. One of the reasons I love it so much is because there is still so much we don't know. And this is just an example of that. I want to make a career out of studying the climate change that is taking place right now because I want to know what's going on. And I'm not fully convinced by the idea that we are the driving force. And now we're going to get into that a little more. So another source of uncertainty. Now, you can call this nitpicky, sure. And I'm going to move on to another one after just because I do feel it's a little nitpicky. But a lot of people talk about Greenland. And the fact is, the decade from like 1939 to 1949 saw more ice melt off of Greenland than from 2012 to 2022. And if CO2 emissions are the driving force of heating and this ice melting, why would we see more ice melting back then when we had less CO2 in the atmosphere? A small example of being like, hey, maybe we don't actually have this as figured out as we want to think we do, and that's not criticizing anyone, because the data are very clear that we are warming the planet. But the data are not very clear about how much we have warmed the planet or the overall impact we've had. So let's get a little technical with this here. We emit CO2 and other greenhouse gases, which cause a warming effect, but we also emit aerosols, which have the opposite effect. They reflect light back out into space, essentially having a cooling effect on the planet. So I'm going to quote a couple of studies here. And this first one was written in 2002. It's a little old, but I think it does a good job of identifying what I'm talking about. But I'm also going to bring up the most recent IPCC data on this topic. So it's not just a 23-year-old study, but more recent data as well. And it says, with uniform priors, the 5 to 95% confidence range for the climate sensitivity is estimated to be 1.4 to 7.7 Kelvin. We estimate the probability of S being outside the IPCC's range of 1.5 to 4.5 to be 30%, with a 23% chance of exceeding 4.5 Kelvin, with an expert prior applied to climate sensitivity and uniform priors elsewhere. And before I go into what this means, there's another thing I want to say. The Kelvin and Celsius use the same exact scale. So this difference of, 1.4 to 7.7 Kelvin is the same as saying there's a potential difference of 1.4 to 7.7 Celsius. If we are going to try to make a definitive claim that humans are the driving force of this warming, we better be able to determine how much we have cooled the planet. Because this 1.4 to 7.7 is a massive range. If we have cooled the planet 7.7 degrees, then what does that mean about this current warming period? If we weren't emitting these aerosols, would we be seeing a much more dramatic warming period? There is a 6.3 degrees Celsius margin of error, according to that study. Now, let's look at the IPCC data. And there is another unit of measurement that we're going to bring up with the IPCC data, and we're going to compare it to what this old study says just to see how things have changed since 2002, and that is forcing. It's watts per meter squared. And this is essentially measuring the energy difference that we are responsible for on the environment and planet. And again, energy should be thought of as heat, right? The more energy you have, the hotter the substance or environment is. And according to the IPCC, there has been a net forcing via aerosol emission of negative 1.1 watts per meter squared since 1750, with a range of negative 1.7 to negative 0.4, again with this huge margin of error and level of uncertainty. And this is one of the primary, if not the primary sources of uncertainty when it comes to trying to define exactly how much of a warming effect we have had on the planet. Now, let's talk about CO2, which is on the other side of this. The IPCC report from 2022 states clearly that the climate sensitivity of CO2 is somewhere between 2.5 Celsius and 4.0 Celsius, with it most likely being above 3.0. So let's analyze this for a second. If we were to take the extremes of both of the values given here, we have cooled the planet by more than 3 degrees, because we've had this negative forcing and climate sensitivity with aerosols that could be as high as 7.7. And the IPCC are reporting a high end of CO2 sensitivity at 4.0. If that is what's going on, and our CO2 has led to this warming that has been somewhat or completely canceled out by aerosol emissions, then we're back to sort of square one of trying to figure out what's going on here. And again, I am not going to sit here and say that that is what's happening, but it is a possibility given the data. And that is this issue with the uncertainty that is rarely spoken about. And of course, if we take the low end of the aerosol and the high end of the CO2, then we've warmed the planet by over 2 degrees. This is just how uncertain the data are right now, which is why it bugs me when people are so willing to definitively say that we are the driving force of climate change, and there's always this sort of anti-human nihilist attitude implemented with it, where it's like we're a scourge on the planet and Earth would be better if we weren't here, which is not true, probably. So one thing, this is just kind of a side thing. Over the past 500 million years, before humans started emitting CO2, there was something of a CO2 drought. There were some studies published like in the 90s that made predictions saying that if we didn't start emitting CO2, then plant life was going to start struggling because of how little of it there was. And keep in mind that even after our emissions, only 0.04% of the atmosphere is CO2. And there were some signs that it may have continued to go lower and lower. And that isn't to make any sort of argument about this climate change. It's just to kind of combat this idea that we are scourges on this planet and that we're terrible for it. It's like we've benefited it in a lot of ways. And one of those ways is that semi-arid regions of the planet have seen a lot more plant growth than they did before we started emitting CO2. It's called the global greening. That's pretty well reported. So this attitude that it'd be better if there were less people on the planet because we wouldn't be emitting as much stuff, I just don't agree with that at all. And I don't think the data do either. So now we can talk about the forcing, which is the energy difference I mentioned earlier. So it's from the same IPCC report. The forcing of CO2 since 1750 has been around 1.90 to 2.41 watts per meter squared, with an average estimate of 2.16 watts per meter squared. If we take the average of each, we have added around 1.06 watts per meter squared of energy into the planet's environment, which may sound like quite a lot, and it is in a sense. It's not something we should ignore by any means. However, the standard baseline for the energy in Earth is 240 watts per meter squared, so we're adding around a watt per square meter to that. Of course, that number fluctuates based on cloud cover, relative humidity, and some other things, adding more to the uncertainty. And I feel the need to say this very clearly. Nothing about what I'm saying here is in any way trying to discredit the impact that we have undeniably had on the planet. The only thing I'm trying to address is the general way this topic is discussed. There is just an absolute certainty from the climate deniers that it's a hoax and anti-capitalist propaganda, and then there's absolute certainty on the other extreme that we're heading towards a melting planet where our children are not going to have an inhabitable planet. Both of those things are nonsense, and they are equally anti-science. And it's also to say that given this high degree of uncertainty, these damages that countries like Germany are doing to their energy and to their people, it may just be completely unnecessary. Now, it may help a little bit with the forcing and the warming, but if we're looking at this realistically, it didn't do anything because China absolutely made up for it within a year, right? This isn't like everyone is slowly deciding to back off. It's that the West is deindustrializing, but China is putting up a new coal plant every 4 hours. It's a joke, but you know what I'm saying. We can move away from the more technical stuff like forcing and climate sensitivity, and no way a comprehensive analysis of what's taking place here. I could make 30 more episodes, each 3 hours long, and still not even really scratch the surface of being able to cover everything. Those are just a really good place to start when trying to identify why there's so much uncertainty with the data. It's in no way saying that you've listened to this podcast now, you should be convinced, or that I've covered everything. No. I wouldn't even necessarily say that I should be viewed as a type of authority on this topic. I have a bachelor's degree in geoscience that focuses in data analysis, so I do a lot of this in school. And like I said, I'm looking for a graduate program, and it's my goal to be an environmental scientist, so there's a reason that I'm so interested in it and do a lot of work outside of school and a lot of studying outside of school. But if you put me in a room with IPCC scientists, I'd probably be the most useless person there. So this isn't in any way trying to refute anything the IPCC says, which is why I bring up their data when talking about it. Again, this is just a good starting point to say, look, we don't actually have this figured out. I want to talk about how this is discussed by politicians and journalists and just the average person. The first thing that comes to mind are the Candace Owens type people who say we shouldn't worry about the climate even a little bit, or people like Donald Trump saying climate change is a hoax. But there's also AOC saying it's an existential threat to our society, and that if we fail to take action now, we may not have a society soon. That is also stupid, and it's harmful. Both of those things are harmful, and I view them as equally harmful. It's not that, oh, Trump's statements are a little more severe and bad. It's like, no, they're both terrible. Right? If you operate off of this AOC assumption and do what Germany did, how many people in America are not going to be able to afford their electricity bill if the energy prices jump up by 70% in 3 years? You know, so this is a problem too that should not be ignored. And I know it's really easy to attack the straight out climate deniers because they almost sound like flat earthers the way they talk about how it's some sort of conspiratorial issue where it's like, I don't think that's the case. I think what's happening here is that there is genuine concern, and that there may be some stoking of the flames when it comes to the misinformation surrounding it, but I don't think the people advocating for shutting down coal plants and opening up solar farms and wind farms are doing so for any other reason than genuine concern for the health of the planet. However, this attitude towards climate change is a direct result of the politicalization of the topic. And I know that Al Gore made this documentary, and that I think was sort of the root of all this politicalization, and I'm not necessarily blaming him. It isn't his fault and his documentary's fault, even though he did make a couple incorrect, inflammatory, sort of sensationalist claims in it, no doubt. He's a politician. I don't think we could expect anything different of a politician talking about a scientific topic. But, it's not his fault that people on the right couldn't hear someone they disagree with say something without having a knee-jerk, immediate opposing reaction to it. But it's also not the right's fault that the left have constantly used climate change as a sort of moral bludgeon to say that I care about the planet and you don't, therefore I'm more moral than you. There's a lot of moral posturing on both sides. The left use what I just said, and the right say, oh, it's a hoax and I'm not brainwashed like you are. So this is just an insanely predictable, comical, and just depressing problem when it comes to this topic. Now, I know I'm criticizing the politicalization of this topic, but it's strange to navigate through because the government should absolutely be passing laws and policies that limit our negative impact on the planet, especially in capitalist countries. And this isn't some lazy criticism of capitalism. It's just a fact that capitalism is completely incapable of putting monetary value on certain things, and one of those things is a healthy environment. Or another example is the Amazon rainforest. How much money is the Amazon rainforest worth? It's not really worth anything. We can put monetary value on the soybean farms that are taking the place of the trees, but we can't actually put a value on the tree. And we can't put a value on a healthy environment or a value on lowering CO2 emissions. They're called unpriced externalities. And the government has to come in and put a certain value on these things, saying, look, you can't go over this without paying massive fines. This is the value for doing these things. And that is a necessary thing for a government to do regarding climate change, CO2 emissions, and deforestation. But again, going back to Germany, we need to pass these policies and do these things in a way that doesn't damage our society. And it's not our government's fault necessarily that our citizens are incapable of having conversations about things they disagree with across the political aisle. However, it can be the fault of some politicians that it's becoming more politicized, and of course Trump's a great example with the hoax claim, and AOC's another good example, and you have governors all over the state like Gavin Newsom saying absurd things about climate change relatively often. Some politicians are absolutely taking advantage of the politicalization of this topic, and they're doing so, to rally their troops and get more votes, and that absolutely plays a role. But, at what point are we going to stop behaving like that and just say, look, here's the data, here's what the IPCC are saying. We don't really know what's going on yet, but we can probably take some steps to make sure we're doing the least amount of damage as possible without skyrocketing energy prices and killing poor people in the process. And while I'm on the topic of lower income groups, it's important to remember that if you want to improve the state of the environment, one of the best ways to do that is to try to get people out of poverty. Because if people are extremely poor, they don't give a fuck about the environment. They're trying to survive. They don't care if they're dumping trash into the river because they can't afford to put it anywhere else. But if you can raise people out of absolute poverty, then you can start improving environments everywhere and putting people in situations akin to poverty by raising their energy prices will do nothing but be counterproductive in that regard. There is another common claim I hear thrown around that hurricanes in particular are becoming more intense, longer lasting, and more frequent. So let's go to the IPCC reports again. And the IPCC also specifically talk about hurricanes in their report. And on a centennial timescale, there have been no changes in the frequency or power of these hurricanes. Power of these hurricanes. Right? And the reason it's important to nail down that centennial timescale is because it is true that in the past 50 years there has been a slight increase in intensity, duration, and frequency, but it seems to ebb and flow, right? And we don't really have a solid mechanism for why that occurs, which is just another thing that we're uncertain about right now. Now, there's an author on Twitter that I've had some interaction with, and he's a pretty popular author, and he is one of the disaster porn human extinction guys, and we've had quite a few conversations, and I just want to talk about that a little bit more. And the main thing I want to address here, I'm not going to thrash him or anything, it's that he has correctly pointed out that the IPCC have been wrong about a couple things, right? They've underestimated warming in some circumstances and in some areas, but what does that mean exactly? Does that mean that we can then go to a scientist who's saying the Earth is about to melt and think that he is 100% right 100% of the time? Of course not. When you're investigating complex issues like this, you're going to get some things wrong. But the fact is, the IPCC is one of the largest groups of scientists dedicated to studying a specific topic that has ever been assembled on this planet. They have the qualifications, they have the funding, they have the resources, they have the people. We value their opinion over people who are like me, even, right? Like if I'm at odds with someone in the IPCC or the organization, listen to them. Don't listen to me. Don't listen to some dude on Twitter who's saying the Earth is melting when the IPCC are very clearly stating that it's not, even if they've been wrong a couple times, because I can guarantee you that dude has been as well. And one of the more annoying things about the hurricane side is that people try to bring up the monetary cost of hurricanes, and that has absolutely risen over the past ever, right? And the reasons for that are pretty obvious and it has nothing to do with the strength of the storms. It has to do with growing populations, putting more houses in areas, and then putting resorts on the beach that get hammered by hurricanes all the time, right? So inflation has raised prices of everything. We're building more shit. We're building more expensive shit in areas that get hit all the time. So monetary damage from a hurricane is in no way a reliable unit of measurement for the storm's intensity. And it's certainly not a reliable way to compare storm intensity over time. That is nonsense, but it comes up way more often than I would have ever expected it to come up. What we need to be talking about with that specific issue is why are we building this shit in these areas to begin with? Have we really not learned from the past 70 years that maybe building resorts on an island off the western coast of Florida is a bad idea? Because you are making the decision to take this risk that we know exists and almost absolutely certainly your property will get damaged. So I think that's kind of the approach we should take to that conversation, not saying this storm cost $5 billion and the one in the 70s cost $2 billion, therefore the one now was more damaging. Like, that's nonsense. But we do need to have a conversation about where we build our stuff because it is kind of stupid. Lastly, I want to start talking about some of the things we can do to start moving away from coal. Because I've made it pretty clear that I'm not necessarily a fan of trying to rely on renewable energy sources. One, because they're not efficient, which is what we're about to talk about. But two, they're just not reliable enough, right? You need to have two fully operational grids, like I said. So let's talk about that for a second. I think the best and most obvious option here is nuclear energy. And I cannot, for the life of me, understand why the net zero and renewable people are not on board with nuclear. And there are a few reasons I think nuclear should be the first option. But I'm going to talk about wind, solar, coal, and nuclear here. And we're going to talk about a couple different metrics of efficiency. And it will become incredibly clear why nuclear should be our first option. So first is the energy capacity factor, which is essentially measuring how often the equipment is producing energy while it is in function. Nuclear plants are producing energy 95% of the time they are operating. Coal plants are producing energy around 50% of the time, solar panels are at 25%, and wind turbines are 40% onshore and 60% offshore. You know, it's obvious why solar panels struggle because the sun goes down, and you're not producing energy at night with solar panels, so, that's not a surprise that they're so much lower than everything else. But I think offshore wind turbines are fantastic ideas. The wind, anyone who lives on the beach knows the wind is insane. But, there's things we'd have to line out. Like, we don't necessarily want it where ships are having to go and things like that. So there's, kinks to work out here and there. But they are a decent supplementary energy source for a nuclear or coal plant grid. Now, there are some weird arguments that I hear about solar panels and wind turbines, and I want to get into that now before I move on to the next efficiency metric. And it's that they are like eyesores. Like, people talk about solar panels and wind turbines and they're like, they're ugly. I don't want to look at them. We don't want them around. They look bad. It's like, are we going to sit here and pretend that coal plants are beautiful pieces of architecture and that they're not just conglomerations of fucking steel pipes and walkways and concrete towers spitting out vapor into the air? Like, coal plants aren't pretty either. I've been on many of them with my job, and they're almost like they're weird. You feel like you're on a different planet because of how like deliberately and honestly perfectly they're designed, but they're ugly. Like they're not fun to look at either. And I'll never understand how energy source debates have a core component that is based in the way the energy source equipment looks. That is just mind blowing to me. I can't wrap my head around that argument, and I hear it so often. Now, let's get back to the efficiency topic. That just kind of got derailed there. But energy return on investment is another aspect of this and partially explains the issue Germany is currently experiencing. This measures the total energy output over time versus the energy it took to make the equipment. Coal plants see a return of 30 to 1, nuclear plants see a return of 100 to 1. Wind turbines see a return of 20 to 45 to 1 based on, if they're offshore, onshore, windy areas, not windy areas. And solar panels see a return of 10 to 30 to 1. In this regard, the renewable compete pretty well with coal, but again, they don't scratch the surface of nuclear. And it also depends on where these renewables are built, because you saw that range of 10 to 30. If you're in a not so sunny area like Washington or Oregon, your solar panel return on investment energy wise is awful. It's just not reliable up there. So again, you're going to have another energy source, another energy grid to provide those people with energy that can't be provided by solar and wind. Now, there is another problem with renewables aside from this having to have two completely operational and reliable grids in place at once, and it's the fact that we cannot store energy effectively at all right now. Our batteries are simply not good enough, and these data are typically pretty sobering whenever we talk about this. So the current state of things, the average battery system that we use to store renewable energy sources are only operational for 2 to 8 hours if fully charged. That means if they have a full charge and we are using all of the power it can to power the grid, it will only work for at most 8 hours, and the average is closer to 4. That is not good enough, because if the wind doesn't blow for 2 weeks, you only get 8 hours of time, and then the rest you have no energy unless you have a coal or nuclear grid to back it up. That's a huge problem. Now, I've read a couple studies recently of these batteries being tested that can power up to 100 hours, and then you have some that aren't as effective at charging but may be able to last a few weeks, and that would be a fantastic improvement. But the reality is we are still a long way off from that being rolled out commercially and it being widely available. Now, you have some house batteries that may last up to like 20 hours because it's not having to power near as much, but in terms of the general energy grid and the batteries that we use for renewables, you get 8 hours max out of them at full charge, at full power. And none, and I literally mean none, of the issues that have been mentioned in this episode today are present with nuclear energy. The only CO2 emitted by nuclear is the CO2 required to build the plant, which is true, of course, with wind and solar as well, but the thing is, with wind and solar, they don't last nearly as long as a nuclear plant would, so you're having to rebuild them rather often. You're having to constantly construct new propellers, or I don't know if that's the right term, for the wind turbines. You're having to fix broken solar panels from hailstorms, and that's not to say there wouldn't be any maintenance on a nuclear plant, but you're not having to rebuild them in any capacity for very long periods of time. It is the most reliable source of energy, nuclear. It is the least harmful to the environment. It has the lowest carbon density per unit of energy, and it has the highest energy return on investment. I cannot understand why the climate crowd is not completely on board and spamming the nuclear energy button. It is our best solution to this issue. So I'm going to wrap the episode up with this, and I'm going to read it off the script because I wrote it deliberately. We should have a 100-year goal of moving off of carbon at a steady and realistic pace. I don't think carbon taxes are a good way of doing this because of the impact it would have on energy prices. Rising energy prices literally kills and displaces poor people. That should not be a collateral damage we are willing to deal with. Humans are contributing to the current warming and climate change we are seeing taking place. But determining exactly how much of the warming we are responsible for is essentially impossible right now. But that likely will change. As we continue to study this topic, learn more about our planet, the cosmic ecosystem in which it resides, the substances we emit into the atmosphere, and the way the planet interacts with them, we will begin to start having more definitive quantitative answers to those questions. Right now we do not. I think I could do 15 more episodes on this topic and still not cover everything. I'm sure I will make another in the future. As it stands, I cannot justify upending our energy grid in an attempt to hypothetically save the planet. First, because what we are doing right now isn't destroying the planet, but also because we haven't even established what the difference in outcome would be if we stopped emitting CO2 altogether tomorrow. There's a funny thing about humans. We are very self-centered. You see this attitude everywhere, all throughout human history. Not too long ago, we were sacrificing people to make it rain, trying to please the gods, convinced that droughts were caused by our bad behavior. So many ancient myth traditions depict floods, and they also make it clear that the reason these floods supposedly occurred is because of our behavior. Now our planet is warming, some places are flooding more than they were before, some ice is melting, and once again, it is our behavior that is the cause. And I'll leave it at that. And I hope you learned something, and I hope you think that I navigated these tricky waters pretty well, or as well as I could. There will be more episodes on climate change in the future, but I hope this was a good starting point and that you learned something. Thank you very much.